Welcome to the deep dive. We've just waded through the latest batch of Google Cloud Platform technology nuggets for the second half of November 2025, and it's a lot. I mean, if you're an application builder, a developer, maybe you're just getting started on Google Cloud, looking at all this dense material, it can feel like a full-time job just to figure out what actually matters.
Oh.
So that's our mission today. We're going to be your shortcut. We're pulling out the most important, the most actionable stuff, specifically for you, the person who needs to build and scale things faster, cheaper, and, a lot smarter.
And if you had to boil this entire period down to one word, it would have to be convergence. It feels like we're really seeing Google Cloud's vision for an AI-native data cloud just click into place. It's not about AI as this, separate thing you bolt on. It's being embedded deep into the data layer, into the infrastructure, into the tools developers use every day. It's all coming together.
And it seems like others are noticing too.
They are. I mean, the sources point out Google was just named a leader in the 2025 Gartner Magic Quadrant for AI application development platforms and for cloud database management systems, too. So that external validation, it shows this unified approach is really working for people.
That's the perfect setup. Okay, let's unpack
That's
that.
right.
Let's start right at the cutting edge AI models. Everyone's talking about Anthropic's Claude Opus 4.5.
Right, and its general availability on Vertex AI. And for anyone who isn't familiar, Vertex AI is basically Google Cloud's unified workbench for everything machine learning. It's where you build, deploy, manage all your models in one place.
Okay, so a new model lands on Vertex AI. What does that actually mean for me if I'm building an app today? Is it just like a bit faster, or is there more to it?
It's both, but the headline here is really efficiency. Opus 4.5, it has that frontier performance. It can handle really complex coding, these tricky agentic workflows, vision tasks, you name it. But, and this is the critical part, the sources say it's way more efficient.
More efficient how?
It costs 1/3 the price of its predecessor, Opus 4.1.
Wait, 1/3? That's a massive price drop. Is that just, a marketing ploy to get people on board, or is it a real architectural gain?
That's the question everyone's asking, but the feeling is that it's genuine improvement. For a developer, the technical wins are really concrete. We're talking about much better tool use. It's smarter about figuring out which tool to use and when, and it has this huge context window for analyzing long documents.
And you can deploy it predictably.
Yes, using provisioned throughput in the Vertex AI Model Garden, that gives you stable, predictable performance, which is just vital when you're in production.
Predictability and a huge discount. That's a powerful combination. All right, let's shift from the models themselves to strategy, specifically security. Our sources had some insights from Phil Venables, Google's strategic security advisor.
And this is maybe one of the most important conceptual shifts for everyone, even if you're not touching AI directly yet. He talks about how traditional cybersecurity has often been like a fire station.
A fire station.
Yeah, you're sitting around waiting for an alarm, a breach, a vulnerability, and then you rush out to put out the fire. It's totally reactive.
Right.
AI just breaks that model. You have to move to what he calls flywheels. Proactive, continuous improvement systems where security is self-reinforcing. It's baked into the process from the very beginning.
So practically, what does moving from a fire station to a flywheel look like for a developer?
It means you stop focusing just on the perimeter wall around your app. You start securing the process itself. It's about having tools that monitor your model's behavior, just like you monitor your infrastructure logs, because AI brings in totally new attack vectors like prompt injection. It's a much more strategic posture.
From frantic to strategic.
I like that. That's a great transition into our next section, which is all about this convergent story getting AI and data to live in the same place and killing that awful context switching developers hate. And the sources are putting a huge spotlight on BigQuery AI. Now, for those who don't know, BigQuery is Google's serverless, super scalable cloud data warehouse. It's the home for all your critical business data.
Exactly. And it's not just for storage anymore. It's really becoming an AI command center.
Yeah.
Now, you can access Gemini models, Google's top-tier generative AI. You can do vector search. You can run inference, all directly inside BigQuery using standard SQL.
Okay, so running Gemini with SQL sounds cool, but why is that such a big deal for my workflow?
It's all about friction. Before, you'd have to pull data out of your warehouse, move it to a totally separate ML platform, do your computation, then pipe the results back in. It was slow, complicated, and a security headache.
And a lot of context switching.
A ton of it. Doing it all in one place right where the data lives just makes everything faster and lets you experiment so much more easily. That's a huge win. And another huge pain point, speaking of experimentation, is building agents. They're non-deterministic, so trying to figure out why one failed is a lot of guesswork.
It's been a black box. And that's what the new BigQuery Agent Analytics plugin for the Agent Development Kit, or ADK, is built to solve. It's basically bringing observability to your AI agents.
How does it work?
With a single line of code, you can stream all of that critical agent interaction data, like what tools it used, how long each step took, what paths it tried, and send it all straight into BigQuery.
So instead of guessing, I can query its entire thought process.
Exactly. You can run advanced analytics on those logs. You might discover, that your agent gets stuck on step 3 because a specific tool call is too slow. It turns agent tuning from an art into a data-driven science.
That's a game changer. And while we're on data, we should quickly mention the BigQuery Data Transfer Service got some nice quality of life updates, better scheduling, better error reporting. Quiet stuff, but important for data engineers.
And tying it all back together, there's a huge breakthrough in forecasting, a model called Times FM. It's a foundation model for time series data, and it's now available directly in BigQuery and also in AlloyDB.
AlloyDB, right.
Yeah.
Remind us what that is.
So AlloyDB is Google's fully managed, really high-performance PostgreSQL compatible database. Think of it for your high-throughput transactional workloads.
And having Times FM in both places means what?
It means you can run credibly accurate forecasts for sales, for inventory, with just a simple SQL query. You get to completely skip building a complex external ML pipeline. It makes advanced business forecasting accessible to way more people.
Taking a data science project and turning it into a function call. Love it. Okay, let's pivot from the data layer to the plumbing. Section 3. Core infrastructure, networking, and databases. And let's start with a headache everyone who has ever gone through a company merger knows all too well, overlapping IP address spaces. It is an absolute nightmare.
That's a huge operational bottleneck. You end up with these multi-week projects just to readdress entire networks so they can talk to each other.
So what's the fix?
It's a new feature called Private NAT for networks with overlapping IP spaces. NAT is network address translation. It essentially lets you map those conflicting internal IP ranges to unique, non-conflicting subnets. So your VPCs, your virtual private clouds, your little isolated networks in Google Cloud can all communicate seamlessly.
Without tearing everything apart and starting over.
Exactly. It just works. It turns a 3-week headache into a configuration setting.
Fantastic. Now, for the most critical apps, we need more than just connectivity. We need, guaranteed resilience.
Absolutely. And that brings us to Protective Reroute. This is a feature that, honestly, it changes the game for high availability apps.
How so? It's not just a faster failover.
It's not a failover at all, really. It's preventative. The system actually detects potential physical network failures or maintenance events in Google's backbone before they can cause packet loss.
Wait, it predicts failures.
It does. And then it proactively reroutes your traffic onto a healthy path before a single packet gets dropped. For your workload, it's just a completely steady, uninterrupted connection. The end user never even knows something happened.
That is some next-level engineering. Okay, let's talk about getting access to this stuff, especially for developers who are worried about costs.
This is really good news for anyone who's wanted to test out the high-end database features, but was, hesitant to spin up a big, expensive instance. Google Cloud now has a 30-day free trial for Cloud SQL Enterprise databases.
In Cloud SQL, is there a managed service for databases like PostgreSQL and MySQL, right?
Exactly. It handles all the patching, backups, the boring stuff. And this trial isn't for some tiny toy instance. They give you an Enterprise Plus instance with 8 vCPUs and 64 gigs of RAM. It's powerful enough to do real high-load benchmarking.
A month of real benchmarking for free is huge. Speaking of power, we have to talk about the scale numbers coming out of GKE.
This one is just jaw-dropping. Google Cloud engineers successfully ran a 130,000-node GKE cluster. GKE is the Google Kubernetes engine, their managed service for running containers. They literally doubled the previous known limit.
130,000 nodes. How is that even possible? What was the breakthrough that let them coordinate something that massive?
It really came down to the control plane. They used a combination of things, like a job queuing system called QE, but the real linchpin was using a Spanner-based distributed storage backend. Spanner is Google's globally distributed database, and it was the only thing that could handle the state of 130,000 nodes at once without creating a bottleneck. They were hitting a throughput of 1,000 pods per second.
It just completely reframes what we think of as the upper limit for scaling containers. And of course, you need the global network to support that scale, so the new subsea cables, Telelink and Devaru make a lot of sense. Okay, let's wrap this all up in our final section. Let's talk developer velocity. How do we get from a great idea to a production-ready app faster?
A lot of that comes down to frictionless deployment. And we're seeing that with models like Gemma 3, Google's new multimodal open model. They've put out two really clear code lab paths to get it running fast.
What are the two paths?
So path one is serverless. You use Cloud Run Google's serverless compute platform and VLLM, and you get an instant API. Super simple. Path two is for more complex setups, using GKE Autopilot, the managed Kubernetes mode, for a really scalable orchestrated inference. You pick the path that fits your needs.
Okay, so you deploy your agent, but then we're back to that validation problem. How do we make sure these non-deterministic things are actually behaving correctly?
Right. Traditional unit tests don't really work, so Google Cloud is proposing a structured approach they're calling the three-pillar framework for agent evaluation.
3 pillars. Let's hear them.
Pillar one is success and quality. Simple enough. Did it do the job? Pillar two is process and trajectory. Did it take the most efficient path? Did it waste money on unnecessary tool calls? And pillar three, which is maybe the most important, is trust and safety. Is it robust against attacks? Is it avoiding biased output?
You need all 3.
You absolutely need all three if you want to put an agent into production responsibly.
Makes sense. And finally, the actual environment where developers work, the console itself. I hear there's been a big overhaul of Vertex AI Studio.
A major overhaul, yeah. Vertex AI Studio is that visual UI for working with models. It's now really geared towards team collaboration. They've introduced this idea of agents as tools, but the thing I love is the new /commands.
/commands, like in a chat app.
Exactly like that. You can just type prompt to get help refining your instructions, or evaluate to check a model's response against a benchmark, and even build to generate starter code. It just tightens that iteration loop for the whole team.
What a fantastic set of updates. Okay, to recap for everyone listening, AI is moving right into your data layer. You can run powerful models using the SQL you already know. The underlying infrastructure is getting smarter with things like protective reroute, basically eliminating network failures. And the whole developer experience is about removing friction from the Cloud SQL free trial to the new tools in Vertex AI Studio.
And I think the single biggest takeaway is that convergence. Data and AI are not separate steps in a pipeline anymore. They're becoming a single, unified workflow. The more you can leverage these tools that let you work on data and models in the same place, the faster and more secure your development is going to be.
The perfect summary. So we'll leave you with one final thought to chew on. Think about that 130,000 node GKE cluster doing 1,000 pods a second. If that is the level of scale and throughput that is now a proven capability on Google Cloud, how should that change your fundamental expectations about the limits of scaling your next big application? Maybe it's time to start designing for limitless scale from day one. Thanks for joining us for this deep dive. We hope this helps you build smarter and scale bigger on Google Cloud Platform. We'll catch you on the next one.